We did it for a long time. How do we know which number is the slope? Sometimes we don't even know if there's a slope. How do we know, though, which number is the slope? What do? It is not x, but we use the x. I'm gonna since I'm recording this, I'm gonna say something I didn't say in the other classes. First of all, remember, we have to have it in that format to even have a slope. You've got to have a variable. It doesn't actually have to be y. In that case, it is the y. It's got to be all by itself on one side. So you got to have an unknown all by itself. And then on the other side, you have to have another unknown that's being multiplied times something. And then you may or may not add or subtract something onto that. So that's not a huge thing you'll have to worry about. But technically, you need to understand that we don't always have a slope, and therefore we don't always have a rate of change. The only time we have it is when we have a variable that's all by itself on one side, pretty much. There we go. Now we're good to go. All right, let's go back to the.
Can you tell me something important, like that I should know in the future?
Everything. I'll tell you right now, I use this all the time in real life.
No, I got a question. Like, what's something I should know in the future?
No, not to teach this class. I mean, in my life, like outside of school, I use algebra all the time. There's an example actually in here, and we'll see that uses algebra. That's a completely, totally real life example. All right. Here's a quick question. I'm not going to spend a bunch of time on this since I'm recording and I want to get to the other stuff. Mario, is the equation number one a function? Explain why or why not. I figured you were looking it up, so you should know the answer. Yeah, you were looking it up, right? That's why you had your phone out? Oh, you weren't looking it up. Oh, then we should put that. All right. Number one. So this is number one. I want to know if that's a function or not. We said the definition of a function is if we have x values that repeat, then we better also have the same y value. If no x value repeats, it's automatically a function. If an x value repeats, as long as the y value repeats, it's a function. If they don't repeat, if we got a different y value, it's not a function. But what's the problem? I don't have any x and y values in here. I don't know my x value. It's an unknown. I don't know my y value. It's an unknown. So I can't look at a bunch of x and y values and figure out if I'm repeating them or not. Like, I don't know. A lot of people said something to the effect of, well, yeah, you have different x and y, or nothing repeats, or something. Well, I don't know what x's and y's are. They're unknowns. That's why I have the variables. But what can I do with this? What did we do for 2 weeks with that? Something similar to that. You just looked all through your notes. What were we talking about? I said we did this when we did this. It's when we use y equals mx plus b. But what did we do with that formula? A lot of time we did what? We graphed it. You could graph this. If you graph this, it would create a straight line. It would start it through. Oh, I didn't write the answer. So the slope, by the way, was -2. Not +2, not 2x, not -2x, just -2. The slope is always the number that is multiplied times the variable. And I will tell you, it's not always going to be x. So for example, you might see that formula. There's no x in that formula. But it follows the same exact pattern, right? Y is an unknown. Well, this is an unknown. We don't know what that is. That's going to be our output. But we don't know what it is. It's an unknown. C is an unknown. Well, so is x. Everything else is the same. 3 subtract 2. So 2 or -2 is still the slope in that problem.
But C and C.
That would just be like this. If I wrote this. I'm glad you asked that. That's the same thing as that. F of x is it's pretty much the same exact thing as y. It's just a different type of notation. It's called function notation now that we're dealing with functions. But they are the same thing. This is just the output. This is just the output. Using this notation allows us to not have to write so much stuff out later in problems. That's the only reason. So that is a function, because if I do graph this, it is a straight line. If we did the vertical line, oh, here's a quick review. If you have a line on a graph, how do you tell if it's a function or not? What's that thing called? We do vertical line test, remember? That's how you need to be able to tell if it's a function or not. I'm not going to go through how to do it. That's, like I said, I'm not reviewing anything today. We got new material. But I will tell you, it's the vertical line test. You need to understand how to use the vertical line test. If I give you a graph like that, and I say, is that a function? You need to go vertical line test, and you would hit 2 points at the same time a lot on that graph. So that would not be a function. All right, now on to the new stuff. Skip that. Skip that. Skip that. Oh, yeah. I want you. Oh, shoot. All right, come grab the whiteboards real quick. Oh, my goodness gracious, you're late.
Goodness, the celebrity's in here.
Come grab a whiteboard, a marker, an eraser, and you need that packet next to
Have
it.
your autograph? Oh.
Hopefully I have enough packets.
I'm never touching this.
I hope I have enough of them.
I'm never watching this again.
This here.
I got touched by someone.
No, this one, you can grab this one. Here's another one if somebody wants it. Well, you still need to get the whiteboard.
Oh, can I get
What?
3 of these?
You gotta go over there if you want more. That's all, I just had that one laying right there. So what do you think I'm gonna say is wrong with this story?
It was dumb. Ain't no story. I got a story.
Hey, at least you owned up to it. Why? Why would you be doing that? I don't get how you what does your mom get on, mom or dad, somebody get on you, and then you lock down and start working, and then when the heat's off, then you're like, yeah, I'll play around again. That's what it takes, huh? So I need to call your mom every day? Is that what I need to do? Mom, grandma, who is it? Who you scared of? You gotta find out who you're scared of at home. Because there's always somebody. Well, actually, there's not always. Some people are scared of mom, some people are scared of dad, some people are scared of grandma, some people are scared of grandpa.
None of those.
And some people don't have anybody. Then there's nothing I can, in all honesty, sometimes there's nothing I can do then. All right, so here's what you're doing on the whiteboard. You may want to make a copy of it in your notes because this would be something you could use in 2 days. Write down that table and fill in the missing values. I'll give you a hint. The top row and the bottom row are based on some kind of pattern. Should be able to figure out what the pattern is. So if you therefore follow the pattern, all of the missing numbers should work out to where. No, I want you to do it. Don't say it out loud. Don't want everybody else doing it, not just copying what somebody says. Yeah, I want to see, because I want to be able to see it without walking around, but if you're done, you may want to copy it into your notes also. So whiteboard first, then if you get done, you can copy it into your notes. First whiteboard. Yeah, you're copying the table and then filling in the missing values. And you can also write down what's in blue too. We'll get to that later, but if you get done, you must. First on that, then in your notebook. Once I checked it and I said, yeah, that looks good, you can copy it in your notebook. That keeps you from making mistakes. Again, this is the new stuff that will be on your exit table. Everything we do today. I want you to write the whole table.
Oh.
Yeah, not just the missing values.
Oh, hold up. I think I just might figure it out.
Finish the table.
Yeah, like copy the table as is and then fill in the blanks. Show them.
So there's the least the greatest.
Has nothing to do with it. You're thinking domain and range. No, this one is going from least to greatest, but
Yeah, that's what I was saying.
that's an accident. Don't count on it always being like that. Now the X values will typically go up in value, but the Y values will not always go up in value, not at all. A lot of times they will not go up. If you look at your packet, as a matter of fact, I'm pretty sure there's going to be some of them on there where they don't go up. Like number, ooh, most of them do go up. Number 12 does not go up. The Y values do not go up. That's actually the only one. Every other one, oh wait, no, I'm sorry. Number 4 also. The Y values are not going up. From least, I mean, they're not going from least to greatest. So I'll give you a minute to copy that down, fill it in. Again, if you get done with that, copy down what's in blue. If you're done with all of that on your whiteboard, then you can put it, yes, then you can put it in your notebook. That's your last step.
I was thinking the last one that's the 3 plus that number. Is it this?
Everybody,
The blue here. Yeah, once you're done with that, copy that, the blue. Once you're done, now the blue you don't really need to write on the whiteboard. I'm sorry. The blue is just a note. I guess that maybe wasn't obvious. Not quite.
What?
Because think about the pattern. How did you get from this number here to what you had there? How would you go from -3 to 0? Add -3 to 0. Oh, you wouldn't add any negative.
No, I mean,
-3 plus +2 is not 0. So you cancel out. Where's your hand?
Mr. 2.
Nope. Oh, can't, nothing worse.
Plus 3.
Very good. Look at your, again, it's got to have a pattern. You have a pattern on the top and on the bottom. They're a little more random on the bottom. They've got to all follow the same pattern. What's the pattern on top?
1, 2, 3, 4, 5, 6.
But what's the what are we doing? Like, what's the pattern part? You're adding 1. There's your hint. On the top, you're adding 1 every time. So try to use that concept to figure out what the pattern is on the bottom. I'll give you a hint. There's 2 numbers right next to each other on the bottom that will tell you immediately what the pattern is.
Like, what you mean by that?
Well, I've said too much already, then you say.
What you mean by that?
I'll give you another minute, and then we'll just kind of move forward. I mean, I still want you to show me your.
Wait, we copied the
Let me see yours real quick.
Yeah.
It is. It was hot in here this morning. That's the funny thing.
See, I
It's
know.
always hot.
It's not hot
Mr.
in here
Gill.
right now. Yes, good.
Oh, no,
Did you get it?
no. I can't wait to pray by the
Then you were like adding.
So what's the pattern? What are you adding? Well, I mean, like each time you go from one square to the next square, what are you adding? Look at the 2 squares that are where you have numbers next to each other. What do you add? So see if that works. And then see if the last one works. Does that work out? Doesn't that mean you're adding 2 every single time all the way? What do you got?
Same thing that I did, you said no. 2 and 3, after the 3, that 0 is wrong. After that 3 is wrong.
So what's the pattern? What were you doing? How'd you get that?
I was on, I just guessed.
Well, what's the pattern? What are you doing every time you move from one square to the next square? One number to the next number on the bottom. Yeah, if you, here's the answer. So those of you still working on it, looks like most people are good to go. If you, now I want to, so again, let's go to 0 noise, I don't want to have conflict. This is not always going to work. I'm going to show you a couple different ways to do this. This is like a more basic problem, which you'll still see some of those even on the EOC next year. If I have numbers right next to each other, that's where I start when I try to find my pattern. So I'm going to always, especially in the X values, I'm hoping, like I'm really, really hoping on the X values, that they go up by 1 every single time. And in this case, If I look at those first two, sure enough, they go up by 1. So that's the first thing I check is, can I just keep adding 1 everywhere? Well, I added 1 here. That would give me 3, but I need to check in that next block because that's going to tell me if I'm landing on the right number or not. And I do. If I add 1 again, I land on 4. Now I know I got the pattern. As soon as I hit the block where I've already got something there and I get the same number, that's when I know I'm doing it right. Now, for example, let's say down here, I say, oh, I'll bet it's the same pattern. I'll bet I'm adding 1. Well, if I add 1, I get -2. If I add 1 to that, I would have had -1. So that's not the pattern. That didn't work. I mean, there's all kind of ways you can do this. Just plug it, just try a number, see if it works. Now, if you get decimals, it gets a little harder because you got to pick a decimal. Like, is it 1.5? Is it 1.4? Is it 1.3?
Is it common to get decimals?
It will be in algebra, yeah. I don't deal with them because I'm trying to teach you concepts more than worrying about the math. But yeah, next year you're going to have much more complex math. Same topics for the first semester at least, but they will give you more complex math to do using that concept.
It's the same thing, just harder.
Harder math. Yeah, just the math will get tougher. You'll still do the same thing we're doing. You just got to figure out numbers that are decimals. I mean, you're going to deal with fractions and decimals. I don't know what you're laughing at. So here's the way that you would really do this. Again, pick 2 numbers next to each other. I got a 1 and a 3 next to each other, right? Well, what do I do to go from 1 to 3?
2.
I add 2, right? Well, let's try that pattern everywhere. All right, so if I'm adding 2, if I added 2 there, well, if I added 2 again, perfect. I landed on 1. That's when I know I did it right. As soon as I get the first number to match up that's already in the table, which means that's got to be 5. So that's a real quick version of how to fill in values on the table. There's only one time when we use that. We'll come back to that at the end, but I wanted to kind of do it as an intro. Here's what the rate of change really means. The rate of change means every time your x value goes up by 1, which is what is happening in this table. Oh, why is my board so jacked up? Yeah. I don't have anything easily that I can get to right now, so hang on and we'll figure it out. If your x values are going up by 1, so that's your input. I'm increasing the input by 1 every time. I added 1 and made it 2, added 1, made it 3. Then the change in the output, the change in the y, is your rate of change. Why not write a 1 there? So what's my rate of change for that table? There's only one rate of change.
That one needs to go.
Oh, that's what happened. What's that? Well, that's the pattern. What's the rate of change? What would we say the rate of change is? Take a guess. You got a couple numbers. Well, it's a number, because remember, the rate of change is just the slope. So it's a number. Why'd you say 3, out of curiosity?
2 and 1.
So you added the 2 and the 1 together? All right, it's not 3. Other people did that too, and I was wondering why they did it. So I see what you're saying. So it's not 3. Take another guess.
Oh, wait.
What's we just said, did I tell you that the rate of change is a pattern yet?
Yeah.
I say the rate of change is a pattern of
Pattern
addition.
is adding to on.
Oh, here, right. I don't think I told you this. You got to write this down.
It's add 2 because the slope is x.
Yeah, if I already told you this, then tell me. But you need to write this down if I haven't said it in this
What's
class.
the rate of change?
Hold on, Lauren. Hold that thought. You're on to something like a bloodhound. So, the rate of change is a pattern of addition. I didn't say that. This is for a linear equation, or a linear function. I guess you should start out with that. So for a linear function, which is written right there, for a linear function, the rate of change is a pattern of addition. So that's why we were trying to figure out what number are we adding over and over again. Because we're basing it on addition, and we're trying to find out if there's a pattern of addition. If there is,
The rate
then
of change is a pattern of addition.
yeah. And this is really only for linear functions. But again, if it's not a linear function, they're probably not going to ask you what the rate of change is. So you really want to worry about that. Now, it gets a little more specific, which is what this note in blue means. If your values, your x values, everybody focus back in on this. Sometimes this is going to be really easy. If they give you a table and those x values are going up by 1 every time, all you got to do to figure out the rate of change is just figure out, well, what are my y values going up by every time? Well, if they're going up by 2, then the rate of change is 2.
I told you it was.
How?
Because every time the x goes up 1, how much does my y go up?
2.
That's the definition of rate of change.
No.
You
So
figure
only
out,
count the y, not the x.
well, you look at both. The x values have to be going up by 1, which is already set up in this table, right? Aren't they all going up by 1 already?
The x.
Yeah.
Yeah.
So if your x values are going up by 1, then you just need to figure out, okay, well, when my x goes up by 1, what does my y go up by? That's the
So
rate of change.
x
How much the
was
y
2.
changes when x goes up by 1.
If the x was 2, y would be 4.
Well, if you wanted to keep the rate of change the same, yeah. If your x were going up by 2 every time, and you wanted to keep the rate of change, well, yeah, look at this. Boy, I'll rewrite it. Let's just rewrite it. So let's say I had this table. 2, 4, 6, and -1, 3, and 7. Let's say that was the table. Again, all the top ones are at, oh, real quick. Always, in a horizontal table like that, x's are on top. You need to write this down. X values are on top. Y values are on the bottom. Always. Even if they're not labeled.
Wait.
If you have a horizontal table, these are horizontal, left to right. I labeled the x's and y's in this one. So you knew x's were on top, y's. Sometimes they may not label it x and they may not label it y. Like I'm going to show you in a minute. An example of that. The x values are always the top values. You don't have to try to figure it out. They just put the x's on top, the y values on the bottom. Input on top, output on bottom. That's always. If you have a vertical table like on your worksheet, the front page of your worksheet, the x's are always on the left. The y is always on the right. Like look at every single one they gave you, x is on the left, y is on the right. So if you don't have a specific label that says x and y, just remember that. If it's like this, then x is top, y is bottom. If it's left and right, then x is left, y is right. So now you just said, well, what if the x's were going up by 2? Which they are now. I just skipped some numbers. This is the same table. If I were to create a table from this and make the x's go up by 1, like figure out the pattern to make them go up by 1, I'd get the same table over there on the left. So all of these are now going up by 4. That actually gets us to that equation right there. The way you figure out the rate of change if they're not going up by 1 is you take any two y values and you subtract them, and then you divide them by the same, like the corresponding x values. So for example, if I said y of 7 subtract y of 3 gives me 4, then I have to take the same two corresponding values, but I take the x's. 6 subtract 4 gives me 2. Well, if I do the math on that, it gives me 2. So you'll always get the same rate of change no matter which values you use in the table. We're going to do more of that, so if you didn't get that, don't worry too much about it. Just since Tyler was asking about it, I went ahead and covered it. All right, so that's something I want you to be able to do for later today. But now your next step in your notes, write that. If you didn't already write that down over there, rate of change, and then in parentheses I wrote slope because they're the same thing. And then that equals that formula, which we're about to go into what that formula means. So rate of change equals y2 subtract y1 over x2 subtract x1. I'll give you a minute to write that.
Wait, write the blue.
You should have already written the blue.
I know what you said.
That.
Oh, right.
Just, you don't have to worry about that little triangle y, triangle x thing. That's not part of it. I did that. That was something I did in a different class. It's not crucial to today. But you definitely, that's the main formula used for this lesson. You need to have that maybe on every page of your notes. You don't have to go flipping through your notes to find it. And I'd also put it on your worksheet that you got today too, somewhere. You're going to use it a lot. You got it all written down, Kayla? Are you typing it up? Is she typing it up? Is that what she's doing? Keeps it locked in. Kayla. Kayla. Are you typing it in, typing the formula in? Yeah. I see that. You're pretty locked into that phone right now. All right, here we go. So here is the new stuff. Now we're getting into like the heart of the lesson. The other stuff, I would love you to understand that. It will make the EOC a lot easier on you next year. You truly get what rate of change is. No, you have a midterm that I make up and then a final that I make up, but it's not the EOC. It's not made up by the state. Depends how mad I am when I make it.
Great.
So just be nice to me in 2 weeks. That last week, actually, no, you got to be nice to me before that because I make it up way ahead of time. And then be nice to me, like 3 weeks before school.
Like a box of chocolates or something?
What's that?
You like a box of chocolates or something?
I can't be bribed. Money means nothing to me.
Yeah.
Now here would have been an example where it would be a little tougher to fill that table in. The top part, not so much tougher, right? I mean, that part, again, I can already see if I can find a pattern of 1, then that means everything's got to be a pattern of 1. So I'd fill that table in, 1, 2, 3, 4, 5, 6. Now, though, I got to figure out, okay, well, what in the world is the bottom? Not 1.5. No.
Not 1.2, 2.5?
2.5. Good. All right. I'm gonna show you how to do it though in a second. First though, let's do this real quick. So if the x values are going up by 1, the rate of change is just what's the y value going up by? So what is the rate of change for this table? Because the x values are going up by 1, right? I already have that. That makes this an easy table. There's a bunch of ways to do it. You can count, literally count from 17 to 32. Or how did you do it?
Fingers.
Did you count?
Yeah.
Counting, well, I'm fine with counting. Trust me, there's nothing wrong with counting. Don't ever think there is. I try not to do it like really obviously in front of certain people, like maybe your boss. Like if it's easy math, don't sit there and count right in front of them. But I don't care.
Honestly, 15 is actually all odd numbers. So.
Well, or just say 32 subtract 17 if you can do that kind of math in your head.
No,
Numbers are easier. So my rate of change, I'm going up by 15. So my rate of change is 15. What is it? Oh, let's get rid of that.
It goes up, so the x goes by 1, the y is rate of change.
Always. That is the definition of rate of change. If your x is going up by 1, whatever your y goes up by in that table, that is the rate of change by definition.
I got that one.
What is it?
3.
So my x's are going up by 1. So my rate of change is just the difference in my y's. So it's 3. Piece of cake, right? All right, let's do another one.
What about that left?
What's the rate of change in that one?
Nice.
Why'd you get that?
Wait, for what?
No, but where the x is going up by 1. Oh, now
X is going up by
it
3.
just got real.
3, 4.
and 9.
Well, what does that mean? So you told me two numbers. I want the rate of change. I don't know
Okay,
what
so
X and Y is.
X. The rate
X is going up.
No,
rate of
X's
change.
aren't going up by one.
It is 9.
That's what the Y is
That's
going
the
up by,
Y,
but the
that's
X's are not going up by one, so we
Rate of
can't
change
say
is
9
three.
is
It's
rate
going
of
up by
change.
3.
Rate of change is 3.
But it's
So
No,
how'd you get
X
3?
goes by 3. Y goes by 9. Goes by 9.
So I'm going to show you this really quickly, one way to do it, and then we're going to do the main way you're really going to do it.
Times 9.
I could make the X's go up by 1. If I wanted to, and this is going to come in handy for what we do at the end of the lesson, I could say, well, you know what? What if I just created a table with all of the X's going up by 1? And now let's fill in all the numbers I already know. Well, I know 2 is 5, right? Oh, these are just ordered pairs, by the way. So 2 and 5 would be one ordered pair. 5 and 14 would be another ordered pair. Remember, a table is just a bunch of X and Y values. So, there. That's just a bunch of ordered pairs. Let me do this go ahead. That's fine. That's fine.
Can I go get a cup of water?
Possibly, depending on when she gets back. I know 14 goes there. I know 26 goes there. What happened to your cup that you used to have? Did you lose it?
No, it's right there.
Oh, all right. No, Brandon. So I know those values, right? I've already got the X's going up by 1. I just got to fill in these 2 numbers, these 3 numbers, and that 1 number. Where would you start? Where I'd start. Where would you guys start?
2.
You'd start at the 3?
I'll start at the 2.
Well, but we already have the 2. I'm saying, where would you try to figure out?
4.
I'll start off at 4.
Why?
No, yeah. No. Wait. What?
Why would you start off at 3? Just because it's the order left to right?
Yeah. I'll start off at 4.
I'll start off.
Here's where I would start. I'm going to start where I have the fewest missing numbers. Like, the
10.
fewest missing numbers
Oh, 10, yeah.
means I only got to figure 1 number out, and then it better be the same jump.
Oh.
So, again, you say all the time, why do we need to know math? Math's not just about learning for it, it's about logic. Like, make your work easier. The logical thing is, don't try to figure out 2 missing numbers if you can just try to figure out 1 missing number. So now figure out what that number would be. What would be the number for 10? What could you add? Try adding a number.
3.
So if I add 3,
Yeah.
3 plus 26 is 29.
And then
3
add
plus
3
29
more.
is 32.
I
Perfect.
agree with him. Yep.
Now, if that's the pattern, and we know we land on that, that's the pattern everywhere.
8, 11, 14. I don't know.
17. I don't know. I give up. 20. 23. And if you'll notice, then I would have landed on 26. So that's how you could fill out the table.
That takes too long.
Now, it does take longer, but it's going to come in handy for another thing that it will make your life, I think, simpler. Even though it takes a little while, it'll make it easier.
Wait, so
Then try
that's not even 9.
So what is my rate of change then?
3.
Yeah, because now the X's, because the X's are going up by 1, right?
Oh, yeah, that's true. Yeah.
And then we have all of our Y's now going up by 3. So my rate of change, I'm just going to write rate of change like that, so I don't have to keep writing it out. Rate of change is 3. So what did we get before? What were the numbers we had before when we just looked at the table?
X was 3 and
Yeah,
9
yeah.
was no.
Actually, was X 3? You guys didn't really look that closely at it, by the way.
2, 4, 5.
Oh, 2.
It's not consistent. None of you noticed that, but that went up by 3. That went up by 4.
Oh, yeah.
It wasn't actually even consistent.
So if it does that, you have to do the other way?
Well, let's see something. That went up by 9 there, right? That went up by 12.
Door's open.
That's actually not open. My magnet thing ripped. So I took it out. Yeah, that's what I did originally until I found the magnet thing. So I have different x's. It's not a pattern that's consistent, right? I have different y's, not a pattern that's consistent. But what if I looked at this using kind of this formula? What am I doing here? What am I doing here?
The second y value and the first y value?
Subtracting.
And,
Isn't that really going to give me the same? If I say 14 subtract 5, isn't that 9? If I say 26 subtract 14, isn't that 12? Am I not really just subtracting to get those numbers? So I'm really doing what it says right there. I'm subtracting y values. Up here, I'm subtracting 8 values. 5 subtract 2, 9 subtract 5, 11 subtract 9. All you're doing to get the rate of change is you're just subtracting, and it doesn't matter which ones you pick, which I'm going to show you in a second. If I subtract and I get 9 and 3, what's 9 divided by 3? Isn't that our rate of change? Isn't that what we just figured out? What's 12 divided by 4? Bet you do. Isn't that the rate of change? What is 6 divided by 2? Yeah, do you even really need to? I don't even think you need to know how to do math to get that next one right. What about this?
What's 3 divided
What if
by
I said 32 subtract 5? What does that give me?
Wait, what?
32 subtract 5. 7. Close. 27, right? What is 11 subtract 2?
9.
What's 27 divided by 9, do you think? Yeah, don't even need to know how to do math, right?
You saw that? You saw
It
that?
does not matter which numbers I use, my rate of change is always going to be the same. So here's the next part you need to know how to do. Let's say hopefully you're starting to get it a little bit conceptually, because again, that will help you next year a lot. Let's say you're still not. Is anybody still writing anything up there? I know a lot of times I get going and you guys don't write stuff, but I don't want to leave. Are you still writing anything, Natalie? All right, so here's the process you're going to find if you just need to get it done for the exit ticket. So now I'm specifically focused on getting a good grade on the exit ticket. Mario, head up. Catherine or Keith, if you guys want to do, Rashawn, if you guys want to do well on the exit ticket, I'm about to tell you how to do well on the exit ticket. If you have a table, you need to see this, and then I'll let you go. Once you do this problem, I need to label any columns. All right, I'm telling you how to do the exit ticket. Don't frustrate me, please. I'm literally telling you what you need to do in 2 days. I need to find any 2 columns where I have 2 numbers. I'm going to go all the way back to the bell work, where we didn't have all the values. I don't even need to fill that table out. I can if I want to. I just need columns where I have both numbers, both X and Y values. And I only need 2 of those. I don't even need 3. I'm gonna take a break because I'm getting frustrated. Tell you what. Why don't I not show you this and just give you the exit ticket on Thursday? I won't show you the lesson at all, and you can just figure it out between now and Thursday. You can keep talking. If you guys want to just keep talking, we can do it that way. Because I'm up here trying to help you out. And you're just carrying it on. Like, that's frustrating for me. Really frustrating. So again, it's all about respect right now. And I feel like I'm not getting any respect. When I'm trying to help you, that's what I don't understand. So please, keep that in mind when you start getting chatty in my class. You realize we got like 2.5 weeks left. That's it. And the last week's midterm. So don't expect any great big exit ticket to help you out. You have a midterm in this class. That'll be your last week. So you have, not for a quarter grade, it is for your you get a midterm grade in addition to your 2 quarter grades. So it will not won't help you or hurt you really for your quarter grade. So you've got maybe only 2 grades left. I would be paying attention if I only had 2 grades to get my grade on. Or could also go down. So don't think that if your grade is okay right now, that you don't do well on this next exit ticket, which is a bigger exit ticket, can still drop 4 or 5 points, your overall grade. So please pay attention and stop carrying on. Here's what you need. Again, this is what you will have to do on the exit ticket. And those of you that are paying attention, I'm not talking to everybody. I appreciate those of you that are paying attention, or even just not being disruptive, even if you're not paying attention. If you have a table that has missing values, that's fine. You don't have to fill the table. If you want to, it will help you in one other thing we're going to do in a little while. Find 2 columns, any 2 columns, where you have an X and a Y value. So I've circled 3. So we have 3 to choose from. We're only going to pick 2. Let me ask you one question out of those. Does anybody, what would you choose? Like, well, what's the X and which? I need to know.
4 and 3.
So you, what else would you use? 4 and 3, and you got to. Why would you choose those? Why wouldn't you start at the left? That's exactly why you do that. Did everybody hear that? Why would I choose? I know it's left or right, and a lot of times we just pick the first one. Why would I choose something that had a negative in it, though, if I can deal with all positive numbers? So that's the first hint I'll give you. Figure out if you can just come up with all positive numbers. It'll make your life a lot easier. So I'm not going to use this column. I'm just going to use the 2 positive columns. Here's your next step. I'm going to zoom. I think I can get this all on the screen if I zoom. Pretty sure. Yeah. All right. So next step. So there's your first step. Find all positive numbers if you can. You may not be able to, like you'll see on the worksheet you're going to do. You can't do it. Some of them have too many negative numbers. If your table is left to right, so it's called horizontal. It's left to right. This is how you will label it. These are my X values on top, always X values on top, always Y values on the bottom. Oh, let me show, I forgot to show you this. This wasn't labeled X and Y when I showed you that table. This would have been your X's and your Y's still though. That's why I'm telling you that right now, because you're not always going to have tables where it says X and Y. All right, you need to label X1, X2, left or right. I'll tell you right now, you technically don't have to do it X1. You could do X2, X1, as long as you're consistent. And I'll explain that in a second. Then down here, Y1, Y2. I want you to tell me, Brandon, what is the value of X in that table? No, what's the value of X?
What's the value of X?
Yeah. No, what's the value of X?
1, 2, 3, 4, 5, 6.
What's the problem with that question I'm asking?
There's no value.
No, there is. I agree, bunch of them. That's the problem. If I tell you what's the value of X, well, which X? I got 4 of them.
That's why I was confused.
I know. That's why I was trying to say that you couldn't figure it out because there's too many X. That's all these little guys are. These little guys right here,
Let's go are.
the ones and the 2, and the let's go those are.
No,
The
it's
one,
not.
Lazar. Let's go, Lazar. So, all the 1s and the 2s are, that just allows me to say, now, I'll ask Natalie. Natalie, what's Y2? Where's Y2 at?
7.
7. Now you know exactly what I'm talking about. The 1s and the 2s are not math. They're not a calculation. They're not squaring. They're not, certainly not doing a square root. They're just allowing me to tell you which value I'm talking about in the table. These are this is the X1, Y1. So technically we'd say that's the first ordered pair. The 1 stands for the first ordered pair. The 2 just stands for the second ordered pair. That's all the 1s and the 2s mean. Don't get freaked out about the fact that there's these little numbers down there. So with that in mind, here's your next step. Once you've labeled them left and right, make sure you label very clearly that this is an X, this is an X, This is a 1, this is a 2. Sometimes, and I even do this, I'll write an X like that, and I'll forget to finish the X off. Inevitably, somebody does that, and then they write a Y value in when it was supposed to be an X value. Just be very careful. Don't rush through this. It's really similar to the last thing we did, the domain range stuff. It's not hard. It's not complex math, but you have to be careful and follow the steps. Yes.
Are you the most best math teacher here?
Probably not. Nah. There are a lot of good math teachers. I don't know. That's a good question. I will say, I think I have one of the tougher classes to teach because a lot of people teach kids that are really good at math. And that's somebody's really good at math. It's easy to teach. Because again, how do I explain to somebody that doesn't know how to do it? How do I explain to them how to do it if you're just not getting it? Like that's the struggle. But I like that. Like I like that challenge.
We're also all mentally slow.
No, that has nothing to do with it. Some people just aren't. Trust me, I know some people that are not good at math that are friggin' smart people. Math's just not their thing. They make really good money. They do very well. They're just not numbers people. I mean, you can be a very smart person and just not be good at math. So don't ever think that at all. So anyway, this is what I would do every time. Do not skip this step if you're struggling. If you're never making mistakes, I'm not going to count off if you don't do this. Write the formula down without the numbers first. Every time you do a problem, write that down. Now, right next to it, pull your numbers in. We already answered this, but I'm going to ask you again. Lazar.
Laser.
He's up. Lazar. What is Y2? What's my Y2 value? No. Look where I labeled it. You missed the key part. I labeled X1, X2, Y1, Y2. So what's my Y2 value? No. No, you don't add anything together. You need to pay attention. This is easy if you pay attention. Say it again, Natalie. Y2. All I do is I find my Y2 value in the table, which is 7. Once you've labeled it, you're not doing any math until you do this. You're just picking Y2 from the table, 7. Now I'm going to ask Lauren, what's my Y1 value? Oh, real quick. You have to write that subtraction sign. That subtraction sign is part of the equation. Way too many times, here's a mistake I see. When there is a negative value for the Y1. So let's say Y1 in the table, like let's say this would have been Y1. That doesn't mean you skip writing the subtraction sign and just write -3. You have to write subtract and then write the value of the number if that's a negative number. Now we don't have that, so it's not gonna, that's also why I tell you to use all positive numbers if you can, because it avoids that mistake. But this subtraction sign is part of the formula, and then Y1 is whatever number's in the table. If it's a negative number in the table, you need to write the negative number in the formula. I mean, I'll guarantee you somebody's gonna mess that up. Already had it happen twice today. So who did I just ask? Lauren, what is my Y1 number? 3, right? Y1 is 3. Who am I gonna ask now? Okay, you. What's my X2? X2, I'm on this one down here. We already did the Y's. So my X2.
No.
And what is my X1, Celine? Oh, no, you didn't answer me. Now, we're not done, but I will tell you, that's the majority of the work right there. If you get math wrong from here, I'm not going to take off on an exit ticket much at all. I will, I mean, if it's really bad math, I'll take a little bit off, but even if it's horrible math, I won't take much off if you get that correct. So if we do the math, that's what I get, but am I done?
No.
Why?
4 divided 2 is 1.
That line means division, right? Remember that. Anytime in math you have a line, something over and under it, that line is telling you take the top and divide it by the bottom. 4 divided by 2. I'll just write it down there. That is my rate of change. No, we took a long time to do that. It won't take you that long because you'll be doing it all. But don't get going too fast. Because if you get going too fast, thinking, oh, this is easy, and you're trying to get done with your test really fast, and say, all right, I get to get on my phone, or I'm really fast, first one done, those are the people that make the error. I'm telling you. You need to be careful. All right, so here's what you're doing. Go ahead and start working on this paper, front page. You're doing the same thing we just did. You're using that formula. I'm going to show you how to label a vertical table real quick. So if you look at that first problem, just so I could check that one piece real quick. We'll use them a lot more next class when now that I've done the lesson. I might have you do one in a minute though. Don't put them up. I might have you say, okay, everybody do number 4. If you already got it done, you'll just copy it on the whiteboard. It's just easier for me to look real quick instead of walking around. Yes.
Yo, what?
Is this one of the problems? Everybody look, is this one of the problems?
Yeah.
All right, here's how you would label the chart then. I think we had all negatives, so there was nothing I could do to find 2 positives. I mean, I guess I could have used the bottom 2, at least I would have had something positive. But you're gonna label the top, whatever 2 rows you choose, the top row is x1, y1, and then the row below that, and again, it might be 3 or 4 below that if you really want to, but then the row below it would be the x2, y2.
Can I do my math on the white?
I'm gonna read it. But remember, you can use this worksheet if you have this filled out for the quiz, for the exit. So if you do it all on the whiteboard, you're not gonna have anything you can use on the quiz.
I'm gonna just copy it down.
I mean, if you prefer to do it that way, that's fine. As long as you have 1 or 2 examples, you should be fine. I don't care what you're doing. This is practice for you for the exit ticket. I do care if you're on your phone all the time. Yeah, I'm talking to you. You could use these for x1, y1, and then these all the way down here, x2, y2 if you want. Doesn't matter. As long as the only thing that matters is that your x1, y1 come from the same row. Like I wouldn't want to have x1 here and y1 down here. They got to be the same row. Or if it's the other type of graph, they got to be in the same column. That's the only thing that matters. Yeah, I could make this x2, y2 down here and then plug those numbers in the formula. I'll still get the same answer. Always. Because the pattern is always going to be the same.
Is this the same as what we just did?
Yeah, just now it's just vertical. Only different. What's that? Not a 0.
Why not?
What?
What?
Which one?
Number 1.
Oh,
How?
I'm thinking the same thing. How? Wasn't even close to 0 or 1. What number is it? That's not number 1, is it? Is that number 1? I don't think so. Or is it?
7, 4, 3, 4. Yeah, it is number 1. 28, 21. 28, yeah.
That's number 1 right there?
Yeah.
How in the world are you getting 0?
-3. -21. Negative times negative. Wait.
Where are you multiplying negative times negative? You're doing that formula still. Same thing we just did.
Correct.
So did you label it? Did you use those 2 rows or different rows?
Bottom 2.
All right, let's look at the bottom.
I think I got it wrong for 2 negatives. I told you negative.
So again, I'm just going to relabel it since the other's not even on the screen. Should be like this. Is that what you have?
Yeah. Yeah. Yeah.
All right. So next step is what?
-3.
Well, I'm going to say next step is write the formula. Just to make sure, again, I'm going to take baby steps. If you skip steps, I'm not going to take off for it. Problem is, if you don't do this step and you mess up, you might risk getting a 0 instead of some partial credit. Now, you do need to show me some work. Like, you can't just write an answer down. You got to at least show me the math, like the numbers part, but you don't have to write the formula every time. I'm not going to take off for that. So what's my Y2? What's my Y1? That's your problem. What's my Y1? What's my Y1?
Negative 21.
Negative 21.
I wrote that.
All right. Now that's where the math gets a little trickier.
No, I already.
What is my X?
I know what I messed up. I messed up on, I put, for the top, I put -3 and -21.
You are the person that did the X's on top, huh? I've had that happen, I think, in every class today. Because the X values are on top sometimes in the, now it's weird that you did it in this table, but in the other table, the X values are on top, right? I get people all the time when it's a table like that, putting the X's on top in the formula, because they're just pulling from the table on top and putting them on top in the formula, and that's not the way it is. So yeah, go ahead and fix it and see what you get, and I'll tell you if I tried or not. I remember the answer for the first one. I don't know that I remember.
But wouldn't it be 24, -3 minus -21? No, it's not. That's where I messed up again.
How do we do subtracting a negative? Do you guys remember that?
No.
It doesn't.
Do you remember keep, change, flip?
Yeah.
That's what that
It
is.
doesn't equal 0?
You keep
That's what I said.
No, that's how.
Keep this.
No, you did it wrong. You did the same thing. It's not even the same.
No, I didn't. No, I didn't.
Yeah, you did.
No, I didn't.
I said.
You did the same thing.
So here's how you do subtracting a negative. You don't remember that. 'Cause I'm not giving you calculators for the exit ticket.
You flip the number. Flip the
You
number.
keep, then you change the subtraction to addition, and you flip the sign of the 21. So what's that equal?
49.
Negative 49.
So what's the bottom equal?
7.
What?
How'd you
Oh, the bottom
Well,
equals negative
the
24.
final answer I think is 7, but not the bottom. What would the bottom be?
The bottom is negative 24.
Did you just say 1924?
Negative 24.
What are those two?
Right? Oh, what am I saying?
The bottom is -3 minus 4. Correct?
That's, but
I feel like I got something wrong, 'cause that
What
doesn't come out right.
Where is the 4?
do you mean -3 minus 4? What's 4?
Where is the 4? We're messed up. Michigan.
X2.
What?
X2.
No. Where's the
Oh.
4 at?
Come on in.
Is this 1?
I think I wrote, oh, no. Yeah, X2 is on the bottom. Yeah, why did I get 3 there?
Exactly.
That's where I made the mistake.
What?
That's where you made your mistake then, Tyler. I just wrote down what you said, I think. That's what you should have on the bottom,
You
right?
do it off.
So if we, again, keep, change, flip. Now what is 49 divided by 7?
Isn't that...
Can you answer the question, or-
Is that 8?
Nope, close.
7.
7. So the final answer would be 7. I
So I got it right.
oh,
I got
yeah.
it right.
You can go.
Yeah, me too.
Trade your phone out.
I got it right, Mr.
You
Gill,
did
right?
it.
You said, I said 7 was right answer, yeah? 7 was also what was on bottom.
Yeah, boy. That was a better score than your layup.
Hey, Tarvis, bud!
You can't even make it.
You gotta put it in there. There you go. Good try. Funny how people pull it out. Hey, good try. You kids. All right, so there's an example. We just fully worked out one now. So you should have an example of the vertical. So go ahead and do that. There is one more piece I'm going to add in like 7 or 8 minutes. Quickly, just to kind of introduce it. It'll be on the exit ticket though. But we're going to do it again.
You should add something the last 5
You said,
minutes.
This is the last one.
We have more time next time.
I'm so good.
It's 137.
I'm just gonna introduce it and then we'll spend more time on it. I mean, I've heard their songs. It's not like a group I listen to. I don't listen to a lot of old music, really. I mean, I'll listen to it when it comes on the radio. It's not that I don't like. I'm just not a big music guy. I listen to it when I'm in the car, when I'm at home, like if I'm working around the house, like cleaning or cooking. Sometimes I'll say play hip hop or play country or play whatever. I have both actually. I have a Google and a They fight it out. They don't like each other.
My mom got an lesson. I got a Google home.
I have in my bedroom, I have the Googles, and in my living room, I have a sound bar that has Alexa.
I have a sound bar and Alexa. No Google.
My brother shot his Alexa.
Yeah, I don't know why I went. Oh, I know why. I had the Googles, and then somebody else got me the sound bar. My parents, I think, bought me the sound bar for Christmas.
Yeah, I got one like a while ago.
Yeah, it was a couple years ago. I
It's
think.
sick for movies, like in your living room.
Yeah, that's why I wanted it, because my TV doesn't have great sound to it. So the only problem is I can't figure out how to get it to work with my TV. It works with cable, but it doesn't work with streaming. So if I stream something, I don't even know it. No, it's a Philips TV. Somebody told me how to do it, and I just never tried it. Yeah, somebody told me there's a cable you can hook up, which I have the cable. I just haven't. All right, practice a couple of these, because before we leave, I'm doing this new thing. So make sure you can do one or two more of these. I don't think it's hard, but you just need to be careful. So the more you practice it and get all your mistakes out now, the better off you'll be when it comes. Don't make your mistakes during the game. Right? Make your mistakes during practice.
Lazar was making so much mistakes in gym today.
I literally went off for a 6-game win streak.
He shouldn't even be playing.
And
That's what I told him.
I wasn't even going that hard.
He was playing his slides.
No, me and Avante, we were just messing around, but they sucked.
You still shouldn't even. Coach probably doesn't feel that he's got to play
all
a
these
gym
shots.
ball.
No,
You saw me make it on my shot.
but Miss
Yeah,
Miller
I
kicked me off the court
like
because
a
I was
30-game
in
win
slides,
streak.
and she said,
Oh yeah, the coach. You better still coach were out there playing ball and gym and slide. Because somebody has been hurt before in gym, and he was not happy. Not happy.
That was huge.
That might have
I don't
been.
even know why.
I don't know. That might have been this year.
I should have made you
Your
walk
team
hard.
might have hurt themselves in gym this year.
I did guard you. See, I had to guard the Zars to make
Now,
sure he
if
didn't
it's
get hurt.
positive, which one are you doing? If it's positive 68, then you don't add them together.
You remember
It's only when
you
you subtract the
hit my eye.
negative that you keep changing flip. Just be careful.
my elbow.
No,
like
that was
that.
negative, was
No,
it
no,
negative
I-
68 in the
no,
table?
my
Which one are you doing?
No, that's.
No, you don't own.
Well, but again, there's a subtraction sign in the formula, so you always have that. What is the number in the table?
65 by
dude, why was everyone
Oh,
going
then,
off with
yeah,
Jerry
the
like making
68
shots?
positive.
He was?
So you don't add a negative in, it's just 38 subtract 68. But you don't use, you always use that when you subtract a
Bro, what's he
negative.
doing?
So you don't use that, you're subtracting positive. You gotta figure that out. There you go. Now, when that gets erased, write that on just write it on your paper. Right there. This is the kind of stuff I'm talking about with you. You hit it, but then you won't write that on your paper, and you'll forget it, and then you'll do something like try to do keep, change, flip. You don't need to do keep, change, flip. So you only do keep, change, flip when you subtract a negative. If you're subtracting a positive, then you just got to figure out what it is, the way we did it, like going in debt, all that kind of stuff.
He did all his work. He did all his work in his head. He just told me. He was dreaming about it.
Dreaming about math? Wow, I don't even think I dream about math.
For 6 divided by negative 1 is 6,
Man, up
right?
my,
Yes, I think that's number 2. If that's what you're getting.
I was like sleeping.
I believe that is correct.
That he would like he had like a pencil and he was gonna whack me.
Hey.
Dude, I said I flipped my cigarette.
All right, I'm gonna give you the next piece in like 2 minutes.
2 minutes.
And I'm gonna do a fast version today, but don't worry, we'll come back and look at it. I do want you to try. Oh, everybody do number 8. Do number 8, the rate of change for number 8, because you're going to need that for the next thing that I show you. So do the rate of change for number 8. Number 8 on the front page, correct.
Easy numbers.
Yeah, that's why I picked 8 as the number for you. Bunch of positives.
Oh, yeah. Oh, wait a minute. Did we?
I think that's right. No, I think you're right.
I want to go in and make a dessert.
I'm not done. I'm not done with it.
When you look at Lazard, then you say,
I'm so
What?
confused.
Negative 30.
Wait, what?
On it, so the bottom number is answer.
Keep changing.
Actually, they're both negative.
I'm on number 4.
No.
Yeah, they are.
That's close.
No, but 5 subtract 10 is negative 5, right? If you have $5 and you try to give me 10, you're gonna owe me 5. If you can give me 5, but then you owe me 5, you can do it. Top negative all. Because you have 38, right? And then you're trying to take away more than you have, so you're gonna go into the
So
negative.
what's numbers?
So the answer is gonna be negative 30.
Yeah, go ahead and keep the whiteboards, because I may make you show me the last thing on the whiteboard, which we're gonna do now. So everybody, take a break from what you're, unless you're finishing up 8, you can finish that up real quick. I'll tell you when you need to look up here, this one right here. So, we on the exit ticket are going to get a question, and you're going to get this a lot next year in this lesson. I'm not going into as much detail as they will next year.
God, my brain's works.
Instead of just asking you what the rate of change is from the table, they're going to ask you this. They're going to ask you to write the linear function. All that means is you need to give me
I remember this.
the slope, which we figured already was 15. So they're going to ask that, but then we need to figure out what the y-intercept is. So if you remember, that is the linear function, y equals mx plus b.
It would be the X.
No, x is just x. We got to figure out what is the y-intercept.
Something like X on the table. What it goes by?
Sort of, yeah, but it's very specific spot in the table. So when I have a line, what's the definition of y-intercept? If I have a line on the graph, what's the definition? Where's the y-intercept for that purple
The
line?
up and down line, straight.
That's the y-axis, but it has to do with that.
Oh, the y-intercept?
What is the y-intercept for the red line?
Yeah, you did it then.
Yeah,
Negative
it's
3.
where the line crosses the y-axis. What's that number?
Where it meets it, negative 3.
What's the y-intercept for the purple line?
One.
That's the y value, right? So y is negative 3, y is positive 1. What's the x value for those two points?
X value. Don't know.
Look at it, it's right there. Figure out, look at the x-axis, what am I on?
Negative 2.
No,
Zero.
I can't.
say it again.
Zero for that one. And
If I wrote this as an ordered pair, am I not on 0 right here on the x-axis? Isn't that 0?
and
Oh.
So it's 0, negative 3. That's 0, 1, right? So here's your next definition. You really have written this before, but just make sure you can find it. The y-intercept. You'll be writing this. The y-intercept is the y value when x equals 0. So if you took a point on the y-axis, so if you took either of these,
you repeat that.
I'm going to say it again. If you took either of these, they would be 0, comma something, 0, comma something. The y-intercept is the y value, whatever the number is in the y spot, when x equals 0. Always. That is every single time in math. It doesn't have to be in slope-intercept form. It doesn't have to be in any kind of form. It doesn't even have to be a function. If your x value is 0, whatever the y value is the y-intercept. So all we got to do is look at this table, and we just got to look at where the x value is 0 and find out what y is.
Can you say it one more time, please?
Yep. So again, the y-intercept is the y value when x is 0 or x equals 0, however you want to say it. So if you look at the table, find where x equals 0, then just pull out the y value. So everybody look at number, I think it's 10 on the first page. Look at number 10.
Number 3.
Look at number 10. Everybody, yo, yo, yo.
10.
Focus. Lock it in.
Ooh.
What is the, find where x is 0 in number 10, first of all. Find where x is 0. What is the y value when x is 0?
0.
That's the y-intercept. Y-intercept would be at 0. It would go right through the origin, actually, 0, comma 0. What is the y value when x is 0 here? A little bit of a problem on this one, huh?
0.
Do you see an x of 0?
No.
We don't have an x of 0 on the table, but wait a minute. You guys are bright, right?
No.
Isn't it based on a pattern?
Yeah.
So if I wanted to go to 0, right, I would just be following the pattern of going backwards, right? So what do I need to do down here to get this number?
Subtract it by, I forget what was the rating, 15.
There you go. You need to just reverse the order until you get to an x of 0. So in this case, it's simple. I'm just going from 1, and normally it will be simple if you can do this. I just need to figure out, well, what number would go there? Well, if I follow the pattern, I'm subtracting 15 every time. So my y-intercept for that,
15.
no, 15 is the rate of change, because that's what we're changing by. 2 is the y value. It's kind of hard to see that. That's a 0. That's a 2. I think hopefully you get the point. So that's how you do. So I want you to figure out. You got 5 minutes. Should be plenty of time. Now, number 8 is a little tougher. For number 8, I'm going to get you started in a second, though. I want you to figure out the rate of change and then the y-intercept. Start on the rate of change. If you didn't finish that yet, I'm going to help you out a little bit with
What number?
number 8 on the first page.
Uh,
Where am I going to put it?
Number 8 on the first page.
Yeah, you should be able to do the rate of change on your own.
Okay. 1.
That one will save here. I'll add a page in, I'll get you started. So here's what the table would look like if I added some missing values. X is -2, y is 2. Then we want to go up by 1, so -1, 0, 1, 2, 3. I'll go to 6. We don't even need all of them. So there's a table that now will go up by 1, and we have the 0 value for x now. So now let's fill in the values. We have a -2. We have a 5 for 1. We have 6 is 10. Now you can figure out the rate of change already. What was the rate of change? Should have already done that.
1.
So if the rate of change is 1, that means whenever I'm going up by 1, which I am now, right? What am I going up by 1 down here? What am I going up by? I mean, the rate of change is 1, right? If I'm going up by 1 here, this is the rate of change. So if the rate of change is 1,
5, 6, 7, 8, 9, 10.
oh, I just wrote the wrong number there. So what's your y-intercept?
Y-intercept will be.
It's 1.
Where is x 0? What's the y value when x is 0? That's your y-intercept.
I knew it was 4.
So that's how you can figure it out from a table when they don't give you the value 0 already. You just do what we did in the bell work. Figure out what the pattern is. You always want this pattern to be going up by 1. Then if you've already figured out the rate of change using that formula, you just keep adding that number every time, or sometimes you might have to subtract, depending on the numbers. And then once you get to the 0, that's your y-intercept. So we'll review that again since we did it fast, but that is on the exit ticket.
Today was a W day.
We give them a back.
Again, game tonight. Your classmate Lazar is gonna crush it.
We're
so
all
go
white.
support him.
We're all white, and you can get him for free.
Oh yeah, that is right. There is a theme. I'm glad you mentioned that. If you go to the game and you don't have to have white pants and everything, but you have like a white T-shirt, you get in free, and you have to have your ID or your phone where you can pull up Focus, like with your name on it.
Like, what do you mean, our
So like,
I mean, the.
Portal, whatever you call it. Yeah, you can get in if you wear a white T-shirt. It's a theme. Every home game has a theme, and you get in free. Tomorrow night, I think, is Hawaiian night. So if you wear a Hawaiian type shirt.
Wait, there's a game here tomorrow?
Tomorrow is only varsity. Do you know what time it is tomorrow?
I think probably 7:15.
7, I want to say 7:15 also. I think that is
The
right.
varsity jerseys go so hard, they have lightning bolts inside their numbers.
I haven't even seen, I mean, I did see them, but.
Yeah, they have lightning bolts inside their numbers.
Yeah, you guys just got, plain.
Over JP's.
Yeah, you can go ahead and put your whiteboards back, please.
My keys! What was you dreaming about?
I don't remember if somebody was coming in after school.
I can't get over the photo of, it looks like a monkey. He looks so cute. He told me, he was like, you were Did you show him the picture? No. He's getting mad. He'd probably take your phone and delete it.
What I have right now is Kyrie 7. So I'm actually the Kyrie 7. The first pair of Kyrie 7s I had, they were actually really comfortable. I love the shoe. So
Oh, yeah, those are different.
Did you feel like my biggest issue with shoes isn't the comfort of my feet, although sometimes I feel like they don't get any good traction.
That too. Yeah, see, my first pair was great. I had like.
I don't like the lining up, but just stay there and
Dude,
make
watch
sure
him
you
be
know
at
when
the
he leaves
entrance
early.
and
And
our
I'm not.
thing. He
Like my
probably
first
will.
pair, it was a great
Because he
shoe. There was
said,
a bunch of
I have
second.
this in
I
my
don't know
phone
if like
here, and he said,
they changed the material of the shoe like randomly. Like it is the worst shoe I have ever
Sometimes
seen.
they'll do something like that. Try to make a little more profit.
It really hurts my feet. Like, but like it, oh no, it's so weird though. Also, when I'm playing defense, I feel so much off the bat.
Yeah.
It's so weird.
I actually don't wear basketball shoes. I have my stuff. I wear like running shoes, like outdoor running shoes, and they are fantastic. Like they've got, although they're falling apart now, but man, they're light. They got amazing grips to them. So I don't play much with you guys, but when I used to play in the gym with some buddies, man, I love them.
I think it changed in the too because when I first saw the shoe and I picked it up, I was like, wow, these are really light. They're great muscle. And I bought them and I was like, wow, these are great. And the second time I bought them, they were
They
like,
definitely do that kind of stuff. They try to save money and then they wind up losing customers. All right, see you guys.
see, coach.
What are you doing before the game? Are you staying here? Are you going somewhere
I'm
and coming
going
back?
home, but we gotta be back by 3:30.
Yeah, I was gonna say, there's not much time to do anything.
So, yeah.
Yeah, make sure you're on
I only live
time.
like 4 minutes away, so.
Oh, okay.
Yeah.
Do you walk here?
I just, my sister picks me up.
Well, like I'm saying, to come back, you have somebody bring you back?
Oh,
or you
yeah,
have to
yeah,
walk?
my sister.
Okay, that's good.
Alright, see you, coach.
All right, man. Let's see what happens when I make sure. Come on in. Did you email that to me?
I couldn't because the connection, like, it won't let me do anything.
Oh, man. Try doing it again real quick. Where were you trying to do it? In a room?
Yeah.
If you go out in this hall toward the end of the hall, why don't
I
you,
found some notes that I took beforehand that I can probably.
why don't you try, because you can still get started without them. And then this way, if they come through, then I can print it out while you're working. And because if you took good notes on that, I would hate for you to not be able to use them if they, especially if you find out that you need them. So go try that. I'll go ahead. I got to find a copy of the test first of all. And she got the stuff too. Oh, right there. Oh, nope, not right there.